This is the practice number 7. This is the last practice of the semester, and it's called external characterization of materials. The materials and the equipment we use. Well, when I arrived to the mechanical laboratory, the guy that is in charge of the laboratory, that is called Victor, he gave me two types of steel, the 1045 and the 1018. I choose to work with the 1018, so he gave me two specimens, one for the tensile test and the other for all the hardness test. So when I start, first I need to identify the machines I need to work with. The first one was the universal machine. Then I got the optical microscope, the hardness machine, all the machines that helped me with the metallographic preparations, the impact test, the tensile hardness and impact specimen, and the encapsulated specimen for the beakers. I do the impact test with the whole piece of the specimen, and I measure the length and the width. I got the length was 54.78 and a weight of 9.52, and this specimen supports a 70 pounds load, and we can see that this fracture is ductile, and here we have three different types of tests. That is the Brinell, Rockwell and Vickers. This is the Brinell test. We use a 2000 kilogram load. The diameter of the ball was 2.4 millimeters, and the result in BHN I obtained is 436 BHN, and the theoretical is 126 BHN. This is a lot of difference, and I will talk about it later. Then I made the Rockwell with the same specimen, the 1018, and I obtained a 16 HRC. Also, the theoretical is way too big. Is 71 HRC. Well, this for us for the beakers, and I obtained a 177 HB and theoretical of 131 HB. Then I do a tensile test with also the 1018 specimen, and what I could see is that the specimen changed the length because it had an elongation, and this is because the 1018 steel is less ductile than the 1045, so this property makes that this steel can elongate more before it breaks. So that's why the 1045 broke easier or faster than the 1018. Well, now for the metallographic, this is a photo for a 5000X. It's supposed that we need to obtain the number of grains, but at 500X I can't really see how many grains are in this picture, so that's why I didn't get the number of grains. But with these two formulas, if this word was clear, and I can count how many grains I see in this section, I can calculate the number of grains. The results I obtained for the experimental and theoretical are too much. The difference is too much because it could be because the machines are not well calibrated, or also because when I saw the result, I didn't write the correct one, or because the steel didn't have the percentage of carbon that it's supposed to. So this may affect the results.